Awesome, cool. So I was just going to ask everyone first and foremost, so we just go down the panel. So what was the thing that, so obviously you guys all came to, or most of you came to previous workshops. Last time we chatted, mostly you're developing your first satellite, you're going to get to orbit. So flying to orbit, what was the thing that surprised you the most, basically, on your mission, and what would be useful for potential builders that are trying to follow in your footsteps? So maybe Tibor first, what was the biggest surprise? Do you have the mic, or give Tibor the mic?
Oh, thank you. So, what is the most surprising? For me, well, the most surprising was, I assume, the very first signal that we received. It was like we were very excited. Like when you, it's almost like when you have a kid born. I thought about our satellite as our child that we worked on for quite a while, and then when everything fit together and it was launched, we were very excited to see that the rocket did not explode, and then.
Yeah, me too.
It was your first flight, right?
Yes, that was my so.
So, and we saw that, okay, we are not going to have an orbit visible until 7 p.m., so the launch was in the morning, and I think the first reception was done in Japan. So I think it was JA5CAW call sign guy who tracks a lot of satellites, and in the afternoon we started tracking and we heard both of our satellites. For me, I think that was the most surprising. We did a lot of testing before, so actually the fact that it worked and it worked as expected was not as surprising, but rather the very first. So after that, we knew that it was going to work.
Sevket is from the TU Delft team, along with Stefano. Introduce Sevket. So same question. So what surprised you the most, and from the mission you guys flew?
Yeah, the most surprising part is for me not the launch, because I've launched CubeSats before, but the most surprising part is that how much you need to fit in a PocketQube. We always talk about it's getting smaller, but the bare minimum offset is always there. Like, you always need to have the MCU, you always need to have your MPPT, you need to have a radio. So things are getting smaller, but it's actually getting denser. So it's becoming more and more difficult to fit things if you really want to match the performance of a CubeSat, because at some point, it's nice that you are trying to build your PocketQube, but for the second one, they're going to ask, okay, you made it smaller, now what? Now why should I fund you more? So for us, it was like, oh, okay. Then we just try to make it smaller and smaller and then add payloads on it. So
try to get your applications on board, so get your funders to buy into your concept and have some sort of payback for them. So flying's great for you, and everybody loves to fly their satellite, but you have to then convince the university or some funder to then fund the next one, which is the big challenge.
Yeah. So we need to provide something better. It's not just I can use all the money, but what do we put into this? And another, let's say, exciting and challenging part, as Stefan also mentioned, was we had to build the satellite during COVID. So at some point, you saw one photo from Stefano's house where there's the cat when he was trying to program it. And the satellite was in my living room, and you can see my electricity bill for every month, and that month is just skyrocketing because of the testing of the satellite. And exciting part, satellite is smaller, but our team was also small. So this is a little inside information. At some point, we needed more hands, but we were out of them because it was me and Stefano who were assembling it. So while we were holding the stuff, we needed to notch down a burn wire for the antenna deployment. We had nothing else to do, so Stefano held the screwdriver and the cable. I held the other side, and then I had to use my forehead to notch the last piece of the satellite. So we always talk about, yes, we do space-qualified things, but these are also part of the development, which are also fun to talk once your satellite is successful. Otherwise, this is a troublesome topic to talk about. So.
Awesome, cool. Thanks, Sevket. So Constantine, we learned a lot in the unicorns, and we're still learning a lot, obviously. So what was the thing that surprised you the most about the whole getting to orbit experience, and then now with the data we're starting to get through?
Well, there's fundamentally two things. First of all, this demystification that you also experienced with the testing where I came in from an antenna perspective, which was not necessarily space-oriented, but it became like that. The point is, I always thought that, when you test in space, there is I'm not saying there isn't, but there is very thorough testing, but there is also this DIY testing of things where you actually realize, oh, wait a minute, this actually works really, really well. You don't need to necessarily go you can actually do it by yourself. I'm specifically thinking about a vibration test with a washing machine. For those of you that know this, if you don't, you should Google that. It's interesting. The second thing
just to clarify, we don't qualify our satellites in washing machines.
We don't. We have
a very expensive vibe table.
We have our own vibe machine. But it surprises me how those DIY tests can actually be very good. Secondly, the licensing procedure. It's funny, you may prepare and have a satellite ready and qualified, ready to go, to be on the go. A big showstopper in a lot of satellites is the licensing procedure. Either the team did not do it in time, or something happened and basically they're running at it too late. It's usually a huge showstopper, which I thought wouldn't be, but it is.
Also, thank you. So, Mustafa, same question. What was the biggest surprise in getting to orbit for you guys?
Yes, thank you. We have launched our satellite in last year in February. It's called Grizzly 263A. One of the most surprise we don't have any umbilical connection for the battery charge. It's really crucial. Our launch is postponed the time, and our satellites went to Alba Orbital and then SpaceX, and then we have to call back for the battery charge. It's most important, and I agree with Konstantin. It's licensing procedure. Also, local licensing procedure is so hard, and especially Turkey.
Problems with that, yeah, I remember.
Yes.
Some last-minute calls to the Turkish Space Agency, yeah.
Yes. Especially Turkey. It's so slow.
Yeah, I just follow up for that point. The thing that we see, so we've flown 23 satellites now, so more than anybody else, and the number one thing that we've seen that gets teams is licensing. So I think the teams are started by engineers usually, or engineering students, or people that are typically fairly techy, because you have to be to build one of these things. But those sort of folks maybe don't like paperwork, and they don't really like dealing with bureaucrats and things, which is fair enough. That's maybe not everyone's specialty, but I would say to teams, apply early and just get a license, and then get your ball rolling. There's certain things you can speed up. You can rush your PCBs. You can pay a bunch more money, and your PCBs might come tomorrow if you find the right person. But an ITU process is an ITU process. It takes 7 months. And if you're not on the system, it doesn't matter how hard you're upset or whatever. We've seen a lot of people miss launches because they just didn't get the ball rolling, and every jurisdiction is different, So in Turkey, I think you were one of the first ever satellites to go through the Turkish system, so they didn't know what to do with you. And some countries are like that. You're the first one in the country, and people don't know. So do you want to?
Yeah, actually, I wanted to mention something about the licensing and orbits. So please, when developing your satellite, remember you really need the license for transmitting. Yes, you can do without one. As in, that's illegal. But yeah, but please follow the rules, because eventually the number of satellites are going to increase, and then we don't want to have fight over those. So don't make other peoples or organizations chase each other. So licensing is really important. Please do not neglect that. Once you start with your satellite, somebody should really look into it, how to do it, how fast you can do it. Or now lately, the number of university satellites are increasing, so everybody wants to use the amateur frequencies. But ITU is also getting tired of this, because now they are almost running out of frequencies to give it to people. Everybody has a niche, but now there's going to be a limit that they will not be able to provide enough frequencies. So then it's going to become, what are you providing for the radio amateurs that you want to use this frequency? I'm talking for the non-commercial ones. And another thing that you should be careful is your orbit. So again, now we don't need exactly licenses for orbits, but you really need to deorbit. So you need to move out of the way eventually, because we still want space to be accessible. Everybody can send something to space. You can send your sock to space. That doesn't matter. But remember that you really need to open up the orbit again so that the next satellites can just come into the orbit. So please don't forget about these things when developing your satellite. Keep it clean the way you want to find it. Just like a toilet, leave the orbit clean. So, yeah.
Just one comment on this, if I may. So, we need to treat the frequency range as a resource, as a natural resource, because it is. So that's why it needs coordination, so that there's no collision of satellites communicating. So one good example, as I showed in my presentation, that some of the frequencies are shared. So there are satellite frequency bands which are used in space, but also as a terrestrial service, they are used for broadcasting TV, for example. So that can be an issue. And one other thing to keep in mind is that if you are using an amateur band or an amateur transmitter on your satellite and also a professional band, that might be a longer time to get a license to, because we had some issues regarding from IRU because they did not want to give us a license for the radio amateur band because we are also using S-band, which is not a radio amateur band.
Yeah, it brings up a good point. I mean, we find that IRU and the amateur, so a lot of people start off as amateur, but at some point they're deemed to be not amateur. So this is a bit grey in terms of who classifies in what category. So we found a lot of people go down that rabbit hole and have difficulties and ultimately end up flying sort of more professional bands. We fly, professional bands. I think a few other teams are starting to go there as well. I was going to maybe just open it up for the floor questions. So we got about 10 minutes. So maybe if people can just sort of put up their hand and if they have any questions they want to ask the panel, and then maybe just who they're going to direct it to as well. So go over here, Stefano. Just shout. we have no more mics, sorry.
Since you're basically talking about licensing right now, can you just provide some kind of indication? Because now we have a lot of different countries. So how long does it take? I can give you the picture that in the Netherlands, within roughly 6 months, this can be arranged. How does it work all over Europe?
Different countries, yeah. So Sevki can answer that.
I'm also from the European side, but before I was in Turkey, and back then we didn't have the national the space agency. So it was like in 3 months we were talking to ITU, and when we were getting a stamp from the Turkish agency, and it was that quick. Now again, it's also getting longer, not just because of the agency, but also because the number of people applying for frequencies are increasing. So it's not easy to just organize this. That was and one more thing about the amateur frequency I just want to mention. When you use the amateur frequency, you have to share your data and decode and everything. So you cannot just have your data for yourself. Just keep that in mind, depending on the mission that you would like to do. So yeah.
Yes, so for us, we started development 1.5 years ago, and we just got our license 1 or 2 months ago, so barely before. Yeah, even with, I think, good connections to national authorities, but from the international side, it takes more time.
Absolutely. Okay. So Konstantin and myself, so we file in Germany with BNetzA, who the German space agency. We have an Alba Orbital company out there, Alba Orbital Deutschland UG. So they're a subsidiary of our US company and our UK company. I think it was quite quick in Germany. It was quite good. So it's the opposite.
About 6 months.
Yeah, 6 months.
There's a minimum. I think this is for all the countries. I don't know. The US is a bit different on that, but basically you have at least minimum 4 months, because they need to send out the letters for coordination. So at least 4 months to 6 months, and then you have the ITU slides from ITU themselves that say it's a 7-year process to coordinate. Of course, that's like a bit of scare tactics, but they're not wrong.
Do you want to comment or yeah?
Yes. Turkey in minimum 6 months for the we don't apply the directly ITU application. We will first the local applying the information technologies, and then the transfer to ITU process, minimum 6 months and more time. Thank you.
I remember the drama.
Just to clarify, because I forgot to mention this, like you never coordinate directly with ITU. You do it with your local comms agency or comms ministry or whoever. That varies from country to country, right? Just that.
Yeah, so the main thing that people screw up is they don't file their license early enough. We've had to kick people off lunches, unfortunately, because of that. And those teams will tell you their horror stories. And we don't like doing it either. It's really not fun for us either, you know. And the other thing is you have to have your license for integration as well, normally, or it has to be like sufficiently lodged with ITU. So you really want to be at least API A, if not API B, which is a 3-month process to get to API A, and then there's a 4-month consultation where, you know, say Mustafa wants to transmit in the band we filed for, we'll get a letter from Turkey and we say, hey, well, we need to coordinate with each other. So yeah, it's the other thing. And the other way you can get around it, or potentially if you're doing more satellites, is we file for 20 satellites on one license. So we're not doing it constantly. So every time we fly a Unicorn, we've already got the license for 20. So we might only fly a few satellites on the launch, but we have a bunch of spare licenses. So that's what we do, and that's worked pretty well for us. Any more questions? Okay, over here. Just shout us.
Yeah, thank you. You mentioned washing machines. So we believe that if a toddler can hold the thing, then it's a certain kind of test. But what other non-conventional tests do you think have actually aided you in preparing for passing the standardized testing?
So who wants to answer that one? Constantine?
Yeah,
You said the washing machine.
Yeah, I said the washing machine, so I'm going to take that as first. So let me reiterate on what Tom said. We're not testing them on washing machines, right? And you've seen our facilities, but yeah. So in the end, the tests I'm talking about, it's, for example, radio testing outside an anechoic chamber. So you want to do it in an anechoic chamber because theoretically, in space, you actually have a lot less, man-made noise, etc., etc. But you also do want to have, test it a bit on a more noisy environment. So that's one thing. The other thing is, until we, that was not a good idea, like bake-out tests until we get a bake-out oven, like try. I didn't say do, I said try. That's very important. That was not a good idea. So that one is a cross X, bye-bye, under the carpet, it's over thing. But yeah, basically, things like that.
I've got a good one, Constantine. So we did some testing at Kai's house once in his oven because we ran out of engineers and bodies. So Kai's helped us with some some functional tests in his oven. So his girlfriend was pretty confused about why we'd showed up with a satellite, and we were commandeering their kitchen for the afternoon. So that's probably my best story for unconventional testing. Any more questions?
Yeah.
Over here. Just shout us.
Yeah. Given your experience in orbit, what do you see as the kind of challenges moving forward when you want to expand and go deeper into space with PocketQubes? What do you see as your challenges for?
So as in beyond low Earth orbit, or?
Beyond low Earth orbit.
Okay, who wants to answer the beyond low Earth orbit one?
Yeah, so I don't know if you follow the news. Now the US put a new rule, like you need to deorbit in 5 years after your satellite is dead. So if you want to go above, so around 500 kilometers, it's 1 to 3 years, depending on your weight. But as you come closer to 600 kilometers, I think it's 25 years. And then as you go beyond, it will be longer for you to deorbit. So they are not going to allow you to be deployed there if you don't have a, let's say, propulsion unit. But if you do the calculations, once you have a big enough propulsion unit, you still don't have enough force to just go down from those altitudes. So going to higher orbits, I think that's definitely a no-go. Nobody's going to allow it because they will consider you as a...
I think they're possibly talking beyond low Earth orbit, so like deep space. So that's like
but
lunar
deep space
and Mars
then,
stuff.
So like for the deep space, it can go as like a secondary payload next to the main satellite, but I still believe that those should also be deployed in a way like those small ones also deorbit around Mars or somewhere, or if they go deep space, let them go like way far away, because eventually those places are also going to be like a garbage orbits. So this is a personal opinion, but I know that you can just use the PocketQubes like an external camera or like a selfie camera for your main rover. There are studies or like, let's say, master thesis in our department who check on the usability of smaller satellites for deep space. Or if there was this one satellite where they want to have a solar sail and then point a laser from Earth, make it to reach 0.2 light speed and go into deep space. So these are just applications. So I think the only limitation for this is just the solar sail itself. I think you can still make the electronics small enough to fly, but it's having the other resources like the laser, pointing, and attitude. So I think there's the possibility. It's just a matter of time. So yeah.
Awesome, cool. So last question before lunch. Who wants it? Have we got any questions? Nobody's got any questions because it's lunch next? Or actually no questions because it's lunch. Cool. So yeah, maybe we can just give a big round of applause for the panelists. Sevke wants to say something.
Yeah, sorry. With me and Stefano, we are the grumpy ones for the satellites. I saw a lot of new faces for the PocketQube. Are there like teams who are developing their very first PocketQube? Can I just see the hands, if there's any? And are you the same team or like separate teams? All 50 of you. Oh, there. And you? Oh, you're on your own for a PocketQube. Okay, that's nice. So yeah. If you have any questions, please find either of us.
Yeah, I was going to say that. Yeah, the guys are going to be mingling around for lunch. So, like, these guys have flown satellites now, so they're more than welcome to help and share any sort of, expertise they can give to you guys. And that's the main thing with the community. We want to help people learn stuff. So we were all clueless when we started, and we tried stuff. We talked to each other. We tried to get educated. There wasn't a lot of stuff out there, to be honest. We'll go on more, Stefano.
Actually, one thing that Craig mentioned earlier is that back in 2003, 2005, for CubeSat teams, there was very much CubeSat on IRC. There was a channel. All the teams back then, I was a student back then, but we knew all the people. There were like few CubeSat launches per year. We knew everybody. This is actually something that is a little bit missing right now. Something like in whatever, IRC channel or anything else. Because at that point, we built a very close link with all these teams. And you see, all the old CubeSat guys, they kind of know each other because of that back then.
Yeah, I think it's a good point. So we've tried to get some group chats going, and they often descend into chaos. Unfortunately, the trolls and name calling and stuff. So there's a Facebook group chat that we've got going, and is not really great just now. There's a WhatsApp group we started with some of the teams as well. So if anybody wants to be part of something like that, we do have some stuff there. I mean, it's not great. We're trying to get people to contribute more, and we're trying to moderate it a little bit better, which is always the challenge with these things. But if anybody does want to be involved in these things, maybe seek out one of the Alba team or Caius or someone. And I think Sevket's part of some of them as well, and who knows, a few other people, I think. So yeah, that'd be really cool if we could do that. So, but we've been trying that for a long time, and it's tough to make it work. But yeah, we'd love to share more information with each other. Yeah. Okay, I think lunch now, so thank you everyone. Maybe we have a round of applause for the panel. Oh, sorry.
Yeah, I was just going to mention that there is the Discord channel from the Flame Trench.
Yeah.
That they've got a lot of good PocketQube CubeSat information. Get on that Discord, just chat. You can try and figure it out.
Yeah, so there's the Flame Trench Discord group. So it's a guy called Ben Cartwright who isn't here, but he runs that. So message Ben or chat to Joe if you want to be involved with that. Anybody else? Or we're going to have lunch. Okay, that's it. Well done, everyone. Big round of applause for the panelists.